Okay, let's start. Hello, everyone. Today's guest is Hema. She's a data analyst, and she's going to talk about big data analysis today. We're very excited to have her here because it's a very interesting topic, very topical discussion, because a lot of people choose this profession right now. So I think we're going to enjoy this one. Okay. Hema, the floor is yours.
Thank you, Lisa. Thank you for the intro. Hello, everyone. Thank you for joining in. I'm pretty excited to be here. So I would like to keep this session interactive. So to all the attendees who have joined here, please feel free to stop me when you have some questions. So today, before I begin, I would like to give you the context what the meeting is all about. So many of you guys will agree with me that we have seen a dramatic changes in the advancements of the technology, right? And it was the changes or the advancements we have seen in previous decades, last 2 decades, it is unbelievable, right? With all the advancements, and there comes a problem along with it. And I strongly believe that. And today's session is all about what is that problem and how did we handle it, and what are all technologies came up in the market to handle those technologies. Give me a minute, I'll put my presentation on the screen. All right. Lisa, can you please confirm if the presentation is on?
Yes, I can see it.
So the title, it says about unleash the power of data. So the data is what the trending now. So with this single click or with every action in the internet that we are doing today is creating a lot of data. You believe in it or not, what happens in a minute, how much amount of data is getting generated with every action of us in our daily life. I would like to show it to you in the presentation. So with the increasing amount of data, so how are we handling it? Have you ever imagined like the tons or the GBs of data we are producing every day, how the giants like Google, Facebook, Instagram, these people are handling it? So I'll get into that. So before we dig deeper into the architecture or the technologies that those giants are using, let's start with a simple thing. So now we talk about what is data. Data is any piece of information that you see on the internet that is created, that is stored for future processing. We term it as data, any piece of information. So all the actions that you are performing in your daily life, like you might be listening to the audio, you might be posting the reels in Instagram, everything we call it as data, but we define it in types. We categorize the data into different types. One such thing is the structured data. Structured data is all about the databases. Many people might have heard about it. We have relational databases like SQLs, which will use to hold the transactional data. Transactional data is something like you can think of bank statements, bank account statements, which you see in your apps or mobile banking systems. And the semi-structured data, there is, you might have seen Excels, you might be familiar with the Excels, but we have something called as comma separated values, which looks exactly the same. Those we term the JSONs or the XMLs, those we term it as semi-structured data. Also, we have unstructured data. So everything else that comes into unstructured, it could be either audio, video, a PPT, an image, a PDF, all that things we term it as unstructured data. Even the likes or views, the comments that you're posting, those we term it as unstructured data. So now comes the hero of this session, big data. So what is this big data all about? Like the name implies, the big data is an extremely the collection of large data sets which gives us the tool, or which gives us an idea to define the patterns or the trends or associations related to our interactions. We call that as a big data. Like the Facebook and Twitter is holding a lot of information these days. So we call that as big data. So when do we define big data? A data as big data. Let's say if I have something 1 GB in my phone, can I call that as big data? That we will see how we categorize that. But like I said before, every minute in the internet, these things are happening. 1 million people are logging in, 45 million people are watching 45 million videos, 2.1 million snaps are taken. All this are happening within a minute. Imagine how many bytes of data, how many gigabytes or petabytes of data we are creating every day. So to handle such data, we should have something to do it with, right? So we'll talk about it. We'll talk about it in a few minutes. So when do we call something as big data, like the data as big data? So all these software, many of the people in the data industry, they define the data into big data based on 5 parameters, 5 V's we call it as. So all the 5 V's are velocity, volume, value, variety, and veracity. But in my personal opinion, we will talk something as data when we have two conditions met that we will discuss. So let's go with the standards that are followed in the industry first. So the velocity is the speed of data getting generated from multiple sources. If there is a continuous flow of data happening, then we call that as big data. Like we are doing is everything. If we don't know something, we'll go to Google and search for it, right? So every day it's happening like 3.1, even more than that, 3.1 million searches are happening every day. So we call that as big data based on the velocity, the speed it is getting, the speed of data getting generated. Based on that parameter, we are calling it as big data. Likewise, we have volume, the huge amount of data. Imagine if we don't have the analogy to define the physical parameters of data, so we are doing it in the bytes or exabytes. If we can give the physical dimension, it will be very huge. So based on the volume, in the year 2002 itself, the mobile traffic per month is 77.7 exabytes. So these data, we call it as big data. Depends on the volume parameter, we can call the data as a big data. And the variety, let's say if we have all varieties of data coming from a single or multiple sources, then we call it as a big data. And imagine if I have a company, I'll have all kinds of data where I can have my employee details, their information, their documents, everything, all sort of the types of data which we discussed before. That if we are getting different kinds of data from multiple sources, then we term it as big data based on the parameter variety. And the veracity is nothing but the inconsistencies or the uncertainties in the data. Let's say the data which is coming, it should not be clean always. There are always ifs and buts in the data. Based on, if we see some data with inconsistencies and uncertainties following all other parameters, we can call it as big data. And the value, if we have a huge amount of data with no value, let's say we are keep on storing our data with no value. Like if we are every day, we might be seeing, right, based on our activities happening in Google or Facebook, we are getting ads. How they are doing it? Based on our actions we perform, that will be stored as data, and the analysis on top of it will lead to those ad generations or those marketing strategies. So when we convert some data to a useful information, then we can term it following all other parameters, then we can call it as a big data. Apart from this, my personal opinion is we can call big data as a big data by considering two parameters. One such parameter is if we have huge amount of value, which already we discussed, and the amount of or the time we are taking to process that huge amount of data. Let's say if my company came to me and asked me to process 1 GB of data, and if I am taking it as more than 20 or 30 minutes in this world, I mean, during this time, I can term it as big data because I'm not using the technologies now. And I can term that as big data also. It always depends on the requirement we have. And we can decide the data as big data, or anything we can call it as big data based on our requirement, considering the volume and the processing time we take to process that data. Let me give a pause here and see if my audience have any other questions.
As for me, I think it's very clear. So okay. Yes.
Now, yeah. Okay. Let me continue then.
Yeah.
Till now, we talked about the problem. This is remember, guys. This big data terminology. It's not a technology. It's a problem. Now we have this amount of data. Now, how to handle with it? We need to find a solution, right? So we will talk about the problems first. What this big data brings us along with it. The good news is we have something to achieve, or something we can get benefit out of the data, but the problems we are facing, how to store this much of data. We should have this sufficient capacity, right? Although the storage capacities have increased during these years, like in the years 2004 or 2005, even that time, our people have seen the vision that the data is growing enormously. They need to figure out the solutions. Even with the advancement at that moment, they could not achieve this problem because they could not handle the data into the physical drives, which are there at the time of the market. Also, let's say they have stored the data, how to analyze it? Because if they had stored the data, dividing it into some X or Y algorithm, if they have divided the data and placed it somewhere in the drives, how to analyze it? To analyze the data, again, we need to combine everything, and we have to do, right? If we do bits and pieces, it will not give us the right direction or the right value out of it. So we have another problem. Though we store the data, we need to combine it first and perform an analysis. So to achieve that, we got a solution. There is a concept called distributed file system, where we started using the small computers, but we can replicate the data, and we can store it all that in a by a master or a slave architecture, which means there will be one. If I give an analogy, let's say I'm a teacher here, and if I have 10 students, I can control it, right? There's in the similar way in distributed file system, there will be one master who will decide where to store what data. So I'll decide as a class teacher, I'll decide what topic I can discuss in the class today, right? In the similar fashion, the distributed file system will have the master and slave nodes, where the data will be stored in slave nodes, and master will be the person who decides where to store what. So we have an option, like nodes are nothing but physical computers which are connected over a network. Over a network, we can connect like 4 GB of RAM computers, like 16 we can connect, and we can build a super node structure, and we can store more data than having 4 GB of capacity, right? In the same way, this HDFS solved our storage problem. Now comes our processing. How do we analyze it after we store? Let's say we got HDFS or distributed file system concept. Somehow we have divided the data and stored it in bits and pieces, like in master slave nodes. In the nodes we have stored. And how to achieve again comes the problem. How do we analyze it? There comes the solution. MapReduce. MapReduce is a programming model. The main purpose of it is to combine the data which is already stored and gives us an option to compute on top of it or analyze on top of it. So we have these solutions, and both of these solutions leads to the term called Hadoop. Hadoop is the framework which helps us in storing the big data and analyzing it. It has two components, like I said, HDFS. One is for storage, and it has a computation layer called MapReduce, which helps us to combine the data and perform the analysis on it. So the goal and requirements of Hadoop is to facilitate the storage and processing of large and rapidly growing data sets. It could be structured, unstructured, anything. So this problem, and we have, let me talk about the history of Hadoop. Like I said, this problem has been identified in the years 2002 and 2003. And the very first hit, the data was hit to the search engines. So Yahoo and the Google were people who were hit by it because they have to handle lots of data with the internet. They have seen the data is growing enormously, and they have to keep all the such results into one place, and they have to navigate it when they click, and they have to index the data they have. So in the year 2003, the people from Nutch, it was started in Google. So the people from Nutch has published two papers, which is which the HDFS and MapReduce. So later the Apache is an open source community. Apache Hadoop has built on top of that papers, and they have changed the name to Hadoop Distributed File System, and GFS stands for Google File System. And later Facebook launches the SQL support for Hadoop. Before it, there was no SQL support for Hadoop. SQL, in the sense, it's a structured query language where it is very popular in the databases, SQL databases, where we can store and retrieve the data. It is used for retrieval mostly. And we have distributions came in picture, which helped the Hadoop to bring it to more wider audience. They have even everyone adopted Hadoop because they see the future of it. And the use cases. Now, everything we see on cloud, that they make it easier, the computing power to run all the data intensive tasks. Hadoop is again playing a major picture. That was the pioneer, I would say. And even Know-Me program from British Airways, they could achieve this increase in sales and achieve the hike in revenue using this Hadoop technology. So why legacy system is not a solution? Why only Hadoop is a solution? Legacy system, like say the general disks we have, or the storage or computing mechanisms we had earlier, why those cannot be a solution? Because we have always a problem of scalability. Let's say if I have one system with 16 GB or 32 GB capacity, if 32 GB got filled, I have no option to scale. The previous or legacy systems had that limitation. Also, they only process the structured data, which means if the data is in a database or row, columnar, those formats, that was only supported by the legacy systems. And it is always expensive to increase the computing power on an existing one single machine. It's always expensive, and it cannot, on top of it cannot process that huge amount of data. Also, it cannot process all the varieties of data. So this cannot be a solution for our problem. There comes our Hadoop. Why only Hadoop? Because it is scalable, it is flexible, it is fault tolerant, and it always allows us to process the data in very high speeds. So what do we mean? The flexibility mean it handles both the structured and unstructured data in the similar fashion. There is no biases involved. So it can handle even the encoded data, which makes it suitable or flexible for us to handle big data. Also, the scalability. Let's say, like I told, HDFS is the component of Hadoop which deals with the storage. Let's say if I have a 6-node cluster, so all the computers connected over a network, we call them as a cluster, and each computer we call them as node. So let's say I have 6 nodes, and my storage is running out. So I can add one more node in a very easy way, and that is less expensive than the legacy system. So which means I can scale at any point of time, and it's not that difficult. so we can call that as scalable. Also the fault tolerant. So in Hadoop has this HDFS component, right? So in HDFS, every data we store, it will replicate in 3 times at multiple locations in the cluster. Let's say I have stored some PDF file, it get replicated in 3 nodes, not in one single node. Let's say if one node has failed because of, we will be using cheaper or less computing capacity for nodes. So if one got failed, we always have a backup, which is not possible in our legacy system, because it is very hard to manage the existing system or existing data. How can we replicate it, right? That's where it comes, the Hadoop become our solution. So we always have this bulletproof Hadoop, we call it as bulletproof in terms of fault tolerance. And also it allows high speed data processing, because it has the map reduce than other frameworks. It has map reduce, so the combining of data is always easy for it. So it has an option to deal with batch processes of data, which is 10 times faster than the mainframes. We have another system earlier called mainframes. I can call it as a legacy system, where even now most of the banks will still use mainframes for its security purpose. But yeah, the processes, it is 10 times faster than the mainframe system, and it's comparatively cheaper than the mainframe system. In 2014, I would like to add one point here. In 2014, Databricks, a team used a 207 node cluster to sort 100 TB of data in just 1 minute. Imagine 100 TB of data. So that's the power of Hadoop. So along with that, so with this pioneer in the technology, we had other frameworks based on Hadoop that came, that the frameworks such as Spark, all of these are built on top of Hadoop. So even now many people will start saying that Hadoop is old. Now we have cloud to have the storage and capacity, and we have Spark, everything we can compute even faster than Hadoop. Yes, it is. But the pioneer is always, everything is built on top of Hadoop only. The basic concepts will always lies the same. Everyone uses the HDFS, the distributed file system concept, and even Spark. In the underlying, it uses the MapReduce programs. So I would like to give Hadoop an important thing when who wants to come and learn data engineering or data analysis. I would like to suggest to understand how Hadoop works first, and then go to the other frameworks available in the market. So it'll make you clear, your foundation clear to step up or to learn with the other frameworks. On that note, I would like to take any questions we have, or I would like to interact with Lisa. If you want to ask something, we can.
Yeah, guys, you can just put your hand up or unmute yourself and ask anything. I think it was very informative. Let me just ask a question. So where do you normally find this data? So you said that like major companies like Google, Facebook store this data to basically like help them market, help them create the product. So they find how many swipes we have, how many likes, follows we have, what are we looking for. How do we find this data for ourselves? Do they store it, and is it private to them, or?
Yes, it is private. It is private to them. So underlying what technologies they are using is what we discussed now. Hadoop is one such technology. One such framework, I would say, that they are using underlying. They have built their own systems too, but the concepts or the framework, it is same. It is built on top of it. So it is private to them. Yes, how they are storing, how they are analyzing the data after storing.
But for example, in Cogent, what data can we use to if you need some project related data, if you need some analysis, where would you find data for it?
Data will be stored somewhere, like we can say, we can store in Hadoop, or we can have as databases, our main source. If we have a limited or transactional data, which I mean daily activities, daily you'll perform actions on top of it, such data will be storing it in database. First, from database, we can move it to Hadoop and we will process it from there. That is one such approach. Usually people follow. They'll have their traditional systems and they keep moving, or Hadoop they will be using it as an archival process, I would say. They'll keep all the fresh data in their traditional systems, and in Hadoop, they'll store all the data. So Hadoop will be always the source of truth for them. So they will perform analysis on top of it. Even if we wanted to do some actions in Cogent, we can have the same system. So we might be storing our data somewhere in our database, or it could be any file systems, right? We can move it to Hadoop and we can work on top of it. And we have other frameworks too now came into picture after Hadoop. One such framework is Spark, which became very popular. So we can we have all these technologies which I talked about. These are open source. So on top of it, we have companies who built their distributions. So the difference between the open source and the company distributions is something we do not have any support for open source systems. Like open source is something anyone can use it. So if I get into a problem, like I am doing an analysis on a data set, I get into a problem, whom should I reach out if I use open source? If we talk about the distributions, if I have a problem, I can reach out to their support team. So these people, after Hadoop came into picture, they built the distributions. One such distribution is Databricks, where it deals with Hadoop and have this additional, the super fast framework now called Spark. So we can import the data to those distributions, also perform analysis. It involves little coding there, the SQLs and other coding there. And there comes, there we do the analysis, and from there we can build machine learning models, everything. Before step we can do with the help of the distributions or the traditional system. But since being it an open source, we cannot reach out to anyone if we are stuck somewhere. I would prefer going with the distributions. We have other people, or we have always the support from the distributions.
Of course, yeah, it's so much like more handy when you have the support than when you have to deal with it by yourself.
Right.
Okay, and I also had another question about Web3. So now Web3 is becoming more popular, and blockchain system that stores information like about transactions, and it's stored on multiple computers all over the world. So it's decentralized data. Is it possible to do something with big data?
I think that is a different technology. There the uses the crypto and the hashing. There are many concepts involved. That will be altogether a different area if we talk about. But yeah, the NFTs and those things are future. Again, they will be future, and we will frequently start hearing about it. We already had, but it will become the future. The blockchain and those technologies will be the future.
Of course, yeah, because it's like decentralized, so it's not controlled by anyone. So
yes, the security and all the benefits, people will drive towards it.
Great. Yeah, so guys, this is your final opportunity to ask questions. If you want, please raise your hand. Check. Okay, so if they don't have any questions, then we can wrap it up here. Thank you very much for coming. It was very informative. It's very good that even like the people who haven't joined will be able to rewatch this presentation, and they can actually they can write question in the comments, and I'll send you the link for the video so you can also answer them.
Thank you, Hema. It was a great session, very clear, lucid. I hope you can continue the series.
Sure.
To enlighten more.
Yeah, sure. Thank you so much for joining in. Thank you so much for your patience and keeping up with me. We'll meet again soon.
Thank you very much.
Thank you, Lisa.
Thank you.
Thank you, everyone.